We are going to learn something new today with our trig functions, but first I had one of my students ask, what exactly is a trig function? Which is a great question because it's one of those concepts that sometimes you just need to see it explained, worked out several different ways before you truly understand what it is that we're dealing with. So before we get to finding angles using trig, I just wanted to explain another way exactly what a trig function is. So first I want to start with types of triangles that we have seen before. Each one of these is a 30, 60, 90 triangle. These are called similar triangles because, well, they're similar to each other, but because they have all angles that are the same, they're each a 30, 60, 90. And what happens in similar triangles is that when they have the same angle measures, they also end up with sides that are proportional to each other. So notice on this one, the proportion of the short leg to the hypotenuse is always 1/2. Short leg to hypotenuse is always 1/2. If we look at, let's see, the long leg to the short leg, you're always going to be able to cancel your two, so they're always going to be in a ratio of radical 3 to 1, radical 3 to 1, radical 3 to 1. And this is no coincidence. This is literally what we've been doing with our trig functions. So if we were to look at how this relates to trig, if we're talking about a sine of 30 degrees, that means that we're always taking that opposite over hypotenuse. In a triangle that has 30, 60, 90, because if it's a right triangle, then if one of the other angles is 30, the other one has to be 60. There's no other way for us to draw this triangle. So for a sine of 30, now we know that sine is opposite over hypotenuse. We've got our 2 over 4, which tells us that our sine of 30 degrees is always the ratio of 1/2. That's what we were looking at earlier. If we looked at this one, 5 over 10 is also 1/2. 7 over 14 is also 1/2. So when you are using your calculator to figure out the sine of 30 degrees, it is literally telling you that the ratio of the opposite to the hypotenuse in a right triangle, if you have a 30-degree angle, is 1/2. It's a little harder to see with the calculator because it is going to give you a decimal and not a ratio, but it is exactly the same thing. So let's look at cosine. And we could look at the 60-degree angle as well, but we're going to focus on the 30-degree. So if we're looking at cosine, now we know that that is adjacent over hypotenuse. So if we look at this first one, our adjacent over the hypotenuse is going to be our 2 radical 3 over 4, which if we simplify that is a radical 3 over 2. Okay, so because our calculator is going to give us a different value, let's go ahead and simplify this and see what our ratio is as a decimal. So our radical 3 and then divided by 2. So you get about 0.866. So notice with the other triangles that if I were to take the adjacent over the hypotenuse, that my adjacent over hypotenuse in that middle one, 5 radical 3 over 10, would also simplify to this radical 3 over 2. We've got our adjacent to hypotenuse in that big one is going to be 7 radical 3 over 14, which also is radical 3 over 2. So in all of these, we're getting that same ratio, that radical 3 over 2 for cosine of 30 degrees. So what that's really telling us is that the cosine of 30 degrees, no matter what my triangle, if it's really big or really small in my 30, 60, 90, it has to be in this ratio 0.866, which is what radical 3 over 2 is as a decimal. So last week when you were solving for a side, what you're really doing is saying, okay, if I'm going to use the 40 degrees, and we could use either one here, I could use 40 or 50, I just have to make sure I use the right trig function. How we're setting this up is saying, if I'm looking at 40 degrees, then the ratio of the sides adjacent to hypotenuse have to be in the ratio of whatever cosine of 40 is. We've got our adjacent over hypotenuse. And what your calculator is telling you, and of course we're going to go ahead and multiply by 8 first, so we don't necessarily need to just find the cosine of 40. But when we find the cosine of 40, it's telling us this is the ratio that they have to be in order for this triangle to be a 40, 50, 90 triangle. So by setting up this equation, we actually have set up a proportion because we're saying that the ratio of whatever cosine of 40 is has to be equal to the ratio x to 8 in this triangle. And then of course we learned we want to go ahead and cross multiply because that's what we do in proportions. And then I wouldn't necessarily just be finding that cosine of 40, I want to find the 8 times cosine of 40, and it's going to tell me that it has to be about 6.1 is my x. But the 6.1 over 8 is the same ratio as it told us cosine of 40 had to be. Alright, let's get to solving some angles. So go ahead and write down example 1. It's important to note here that we're really going to set this up exactly like we've been setting up any of our trigonometry problems. We're going to use whatever sides we have. If we have all 3 sides for some reason, I can pick any 2, but I'm going to use the 2 sides that we have. And then for this one, we're going to be looking for x. So I want to use whatever trig function relates to that angle. So I don't want to use this one. I want to use the one that they gave me. So for this x value, I've been given the opposite side and the hypotenuse. I'm asking myself, just like I did last week, what trig function uses opposite and hypotenuse? Hopefully we're getting a little better at that. Hopefully you said sine is opposite over hypotenuse. And I'm just going to say sine of x, because I don't have an angle, is equal to the ratio 15 over 19. Okay, so our setup was the same, but at this point we're kind of stumped because the x is actually the angle inside of the sine function, so it seems like it's kind of stuck there. So in order to get x by itself, I'm going to need to know what the opposite of sine is. I need to know what the inverse operation of sine is. And we use inverse operations all the time, we just don't really think about it a whole lot anymore. Like the inverse of addition is subtraction, the inverse of multiplication is division, the inverse of raising something to the second power is square rooting it. So it's that operation that we do if we're trying to undo what's being done to x in an algebraic equation. So we need to know the opposite of sine, or the inverse of sine. It is actually called sine inverse. So you could say this as sine inverse of x. So sine inverse of x, or just inverse sine of x is fine too. So either way, sine inverse of x or inverse sine of x, that's what we're talking about. So if we are trying to get that x by itself, what we're actually going to do is take the sine inverse of both sides. On the left side, if I take the sine inverse of sine, it's going to undo it, just like we took the square root of something squared. On the right side, I'm going to have sine inverse, because we sine inversed both sides, of 15 over 19. Okay, so this is where your calculator comes in. Our sine inverse is right above sine on most calculators. Even if you're using your cell phone, it has a sine inverse as well. Or you could use the Desmos calculator, desmos.com. But if we're looking at just a regular old calculator, usually right above sine is sine inverse. And so we'll have to shift and then choose sine. And so it'll say sine inverse there of my 15 over 19. And in that fraction, I definitely want to go ahead and put it in parentheses, dividing them. And it's going to tell me that if I have this ratio of 15 over 19, then the angle that it came from had to be 52.14 degrees, something like that. Okay, so for example 2, go ahead and write this one down. I want you to go ahead and set it up on your own. So pause the video, write it down and see if you can at least do that setup part, because that's not really new. Decide what trig function you're going to use and set it up. Go. So you should have chosen tangent, since we have the opposite side as 24, and they also gave us the adjacent side to x is 13. So we chose tangent, is that ratio 24 to 13. And then my last step is just to take the inverse tangent of both sides. So just like I did with sine, my inverse of tangent is inverse tangent. So I've got the inverse tangent of my 24 over 13. And it's going to tell me that that angle is about 61.56. If you don't have a scientific calculator at home, but you do have an iPhone, here's something that you could use. If you open up your calculator app and then turn it sideways, we'll change it into a scientific calculator. In order to put in inverse trig functions, so putting in that last one, the inverse tangent of 24 over 13, you're going to have to put in the ratio first. So the 24 over 13, hit enter. And then in order to take the inverse tangent of that, you're going to hit second, just like on the calculator, and that's going to change your trig functions into inverse trig functions. So we hit second and then tangent, and that's going to tell us the angle is 61.56 degrees. If you don't have an iPhone or a scientific calculator at home, there is a really good website, desmos.com, that you could play around with. Make sure you're on the scientific calculator and not the graphing one. Let me know if you have trouble accessing a calculator or using one for inverse trig. The last thing that I want to leave you all with today is that even though we shorten the trig functions, we abbreviate them, we don't abbreviate how we say them. So when you see like SIN, we still say sine, cosine, and tangent, no matter if it's abbreviated or not. If you've ever heard maybe your parents or your grandparents say mimi instead of meme, that's what it sounds like. So please don't do it. Say the whole word. See ya.